Hello, the next video is on end behavior. So last year you should have been introduced to end behavior and gotten a little bit of a formal in the polynomial unit of how end behavior is. So first at the top, and I will try to make this bigger. Okay, so first this is how it is written. So in your notebook, please star this because this is the most important. All end behavior starts with as X, and they do a little line that says approaches. And some I've seen negative infinity to start with positive infinity, but that's up to you. So we start with usually as X approaches positive infinity. Then what you are trying to figure out is what is Y doing. This is the only part that changes along with the next line. So then this one is as X approaches negative infinity. Again, what is Y doing? So these are what changes, and you're looking at the graph board, or you can follow the chart and able to look at the equation. So you always have access to Desmos, so you can be looking at every graph if you are a visual person. But I am going to discuss in this video how to actually look at the equation and tell. Okay, so one thing you might want to note as well is that as X approaches positive infinity is what is the right doing. As X approaches negative infinity, what is the left doing? So that way you're always looking at it. And then this is a chart. I also have it on the next slide if you want to take the time to write it down. But I'm going to explain this chart as we go through the examples. So first let's start by looking at the graphs. And then we will use this chart because this chart here is for equations. It basically gives you in detail how you can look at an equation and know, and we're going to talk about that in a second. And you can see as their examples here in the middle, they started with negative infinity. I'm okay with either one. I've seen both. If you want to put as X approaches negative infinity first, then do that, okay? So I'm going to scroll down to the bottom so we can see the examples, and then we'll go over this chart as we go. And you can refer back to it to understand what it is. All right, so for this one, you look and we say, what is going on the right-hand side of the graph? Well, on the right-hand side of the graph, it is pointing up. So we would say as X approaches positive infinity, Y also approaches positive infinity. Now look at the left. What am I doing? I'm still pointing up. So as X approaches negative infinity, Y also approaches negative infinity. Okay, so the next one, do the same thing. What is happening on the right? I am pointing up. So as X approaches positive infinity, so does Y. Well, what am I doing on the left? I am pointing down. So as X approaches negative infinity, Y is also approaching negative infinity. Okay, and those are the two examples. Now if we have to move this over a little, okay, and let's look at this. Here we start to get a little bit different. And this is where the pre-calc comes in, which is a little bit different than what we did in Algebra 2. So if I was to draw these arrows, you can tell I have a horizontal asymptote here. Okay, so on both sides of these graphs, on the right-hand side again, let's look here. As X approaches positive infinity, my Y is actually approaching this 1, 2, positive 3. As I look to my left, I'm again approaching this positive 3. So as X approaches negative infinity, Y is approaching 3, which also in this case happens to be a horizontal asymptote. Okay, so the last one has the same thing going on. If you look at this, my graph does not cross 2 or negative 2. All right, and then if you really look closely, where do you think these graph as it goes down is approaching? What is that one approaching? So to me, for this one, this is a very complicated function, would be as x goes to the right, I am approaching 0. As x goes to the left, I would say I'm still approaching 0. Follow those arrows. That will best help you understand what is going on. So for these two examples, I would never expect you to look at the equation and know that. Those two would be ones you would need the graph. Now we're going to look at the equations and talk about what's at the chart. To sum up the chart, the big things that you want to get from the chart, and I'm going to put it down here. So the chart states if it is an even power, so the highest power is even. All we care about is that highest degree, okay? Hopefully you guys remember highest degree. That's your biggest exponent, and it does not have to be the thing that comes first. If that highest degree is even, the end behaviors are going to be the same. No matter which side of the graph, it's going to be the same. If it's odd, they're going to be opposite. Okay, so that's the first part of the chart, is the even or odd, tells you whether they're the same or different. The leading coefficient, now again, the leading coefficient is not the first number necessarily. Okay, it could be the third. The leading coefficient is the number in front of the highest power. Okay, so if this leading coefficient is negative, then the right hand side is also negative, is going down. Okay, if this leading coefficient is positive, then the right side is going up, and that sums up your chart. You can look at the chart for a better detail, but that is the quick little summary. So now let's look at this. So what I'm going to do is I'm going to highlight the leading coefficient. So find the highest power. My highest power here is the x minus 2. Therefore, it was not the first one, it was in the middle. So we go through its even, so we know they have to be the same. X approaches positive infinity. This is why I sometimes start with y when I'm trying to read my function. This explains a lot. Okay, so as it goes to the right, because this is positive, I know y also has to go to the right. Now I can go to the negative, the left-hand side, and I know because this is an even power, these two have to be the same. So even though your chart started with the negatives, I technically always start with the positive because it's easier, because based on these two things, if I start at the positive, I can look at an equation and know. So let's try the next one. This is an odd power. So think back to what I just said down here. And also look at the leading coefficient, and the leading coefficient is positive. So let's think about what we have down at the sum up. So x, as it approaches infinity, because this is 2, a positive 2, y also has to approach a positive direction. Now, because they are negative, this has to be the opposite, making this negative. Okay, now this is an easy way to quickly look at it without having to take the time and actually go to Desmos and graph it. Now you always have the choice to go to Desmos. I'm the type that likes to look at the equation and know, because it saves time, but if you are having trouble following along with that, know that you can always look at a graph to back up your decision. Okay, so let's highlight our leading coefficient again. Leading coefficient is the highest power, which is the 7. All right, so let's look at this one. It's a negative, so this time my right hand side, so as x approaches positive infinity, because it's negative, y has to approach negative infinity. So now we look at what happens to the left-hand side as net goes to negative infinity. Well, it's an odd power, so it's opposite. So this side is positive. All right, hopefully you wrote down some notes. On the next slide is that chart again, so you can look at the chart. And remember, if you're visual, you can always use Desmos.